Hi, students. It's good to check back in with you. We're already at the start of week 3 here of 10. So this week we'll be starting to look at specific molecules that are inside food, as well as some of the food sources that we'll take a look at. And we're also going to begin the Omnivore's Dilemma, which is the one book that I asked that you would get a hold of. So without any further chatter, let me just say a few things about carbohydrates. And then, of course, as always, if you have any time or have any questions, just drop me a line at our ISILO, IASILLO, at robertmorris.edu, and I would be happy to help you. If you did not get the week 2 assignment in, please access that. If you can't get it on Blackboard anymore, you can get it in the instructions. There's a copy of it, and then you can just email it to me, and I'll correct that for you. So we're going to look this week, like I said, at carbohydrates. And remember, there are 2 pieces to our carbohydrates: sugars and starches. So those are going to be the things that we're going to concentrate on this week. All right, so let's first look at our carbohydrate. You can see we have carbon, hydrogen, and oxygen. And one of the characteristics of the carbohydrate is that they have a there's a written rule as to the number of these. For every 1 carbon, there are 2 hydrogen and 1 oxygen. So you have that 1 to 2 to 1 ratio that is kind of characteristic of the carbohydrate group. So keep that in mind. The functional group is what we call an hydroxyl, which in molecular language is hydroxyls are OH. Right? And then usually anything that ends in OSE is going to be a sugar. Right? So if you're reading a label or something like that, and you see galactose or sucrose, any OSE, you can pretty much assume that it's going to be a sugar for you. Here's a lot of information about carbohydrates. One of the key things about carbohydrates is that about 2/3 of the foods that we eat are going to be carbohydrates, right? They're either going to be sugar-based or starch-based. So when we're eating our pastas, our breads, our grains, as well as our sugars, we're eating a carbohydrate. So we'll take a look at where we can find all of these. So first, the function. They're important. They're going to be our main source of energy, right, to keep the cell going, development of the cell, maintenance, all around, just kind of taking care of what is going on in the cell itself. Carbohydrates in the form of cellulose are also the structural component of the plant cell, so extremely important there. Our short-term, immediate kind of form of energy that we're going to get is a sugar by the name of glucose, and glucose gets that formula C6H12O6. Right? Whenever we see that, that's what we consider to be a monosaccharide, and that's going to be our glucose. And when we store our energy, we store it in a form of our carbohydrates called glycogen. It gets broken down in the liver and usually stored in our muscles. So take a look at all of that. So we have our three basic types here of carbohydrates, right? Mono, of course, means one. That's going to be our C6H12O6. You have a disaccharide, which would be two. Oligo is more than that. And then our polysaccharide is going to be 10 or more of our monosaccharides that are bonded together. So we have 2, 3, 4, 5 carbohydrates. So the monosaccharides are, what we encounter most. Those are very simple sugars, and we're going to look at those right here. So here we have a couple different monosaccharides. Glucose, and again, the OSE, galactose, OSE, fructose, OSE, those all indicate that these are sugars. Now, when we're looking at these monosaccharides, I'll move myself over a little here, we see that these all have 6 carbons, right? We're using this hectagon here. So 1 carbon, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. And then 1, 2, 3, 4, 5. This is a 5 carbon sugar. A little bit different. So, when we give that glucose, C6H12O6, we know that we have that. I have any type of pen here. Let me see. I can write with, got a pointer. Doesn't look like I have a pen. All right. So, move myself back over again. All right. So those are our kind of our simple sugars. The glucose are going to be strung together to form. This is our monosaccharide, so a disaccharide, a trisaccharide, and so on. The lactose we see normally in milk sugar, and then fructose, of course, sugar that we see in different fruits. Oligosaccharides, anywhere from 2 to 10 monosaccharides put together. And then when we get over 10, we get into the polysaccharide. So here's just some listings, just to give you an idea. A disaccharide means there's 2 monosaccharides put together. Trisaccharide, of course, 3, tetra 4, penta 5, and so on, all the way up. And of course, we notice anything OSE is going to indicate that we have a sugar. Disaccharides, again, we put 2 together, 1, 2, 1, 2. And sucrose, lactose, and maltose are all of our disaccharides. Again, if you're reading labels, this happens to be, just a chart that, looks at sweetness in sugars and artificial sweeteners, so you can see exactly what we're putting together as far as sweetness goes. One of our sweetest, of course, is sucrose, and then we start to get into more the things that are artificial, and you can see how sweet they happen to be. Poly, of course, 10 or more monosaccharide units put together. And some examples of those polysaccharides are going to be our starches, which we can't digest, right? Our pastas, our grains, and so on. Glycogen, which is going to be the type of polysaccharide that gives us a lot of energy, and we break that energy down. We break that polysaccharide down in the liver, and then we store it in our muscles. And then fiber is that are indigestible. They're not digestible, say. These are things that we take in to our bodies, like corn, for example. Any plant plant parts, our bodies cannot break them down. So lettuce, stuff like that have cellulose in them, our bodies we're incapable of breaking those down. So it's fiber in our diet, and it's a way of kind of keeping everything moving through our system. So cellulose, as I said, structure to our plants, glycogen stored in the muscles, and the liver breaks that down for us. Just another look at the molecular structure here of starch, just to give you an idea of the complexity. Starches are polysaccharides, so there are many more monosaccharides strung together. Cellulose, which of course gives structure to our plants. This is the fiber in our diet. We can't break it down. Glycogen is a type of sugar that gets broken down by the liver, stored in the muscle tissue. This is usually we get it from meats and not found in plants at all. So we have to have some sort of protein in our diet so that we can get this glycogen into our system, because plants are not going to do it for us, and we need that. And then I just put together a couple of things here for you. There's a little concept map which kind of breaks down the carbohydrates into the various parts. Hopefully that'll make that a little easier for you. And then the other thing I put together is kind of a summary of the carbohydrates that we have. Remember, mono is 1, di is 2, and poly has to be 10 or more. Right? So much more complex. So again, if you have any questions, just let me know. I can put something in here. Put that up for you. Hold on a second. Let's see. Can't do that. Hold on. I don't know why I can't get a pen. I don't think I should be able to do that. Doesn't look like it. Well, it's unfortunate. Thought I'd be able to write my name down here, but I don't think I can do that. So again, if you need me, my email is risillo@robertmorris.edu, and I'd be happy to get back to y'all. Hope you have a good weekend. I think I'm going to extend our deadline from Friday at noon to maybe Sunday at noon, so that we'll have an entire week to complete the assignment. Take care, guys.